Good morning. It's April 3rd, and this is your daily brief in science. Here's everything you need to know. A new breakthrough in pediatric cardiology has emerged with a dissolvable pacemaker that is smaller than a grain of rice. This innovative device, detailed in a study published in Nature, aims to address the urgent needs of newborns born with heart defects, which affect approximately 1% of infants each year. Key researchers, Professors John Rogers and Igor Efimov, highlight the importance of miniaturization in creating less invasive solutions for pediatric heart surgery. Traditional temporary pacemakers often require external wires and electrodes, leading to complications during critical treatment periods of about 7 days. In contrast, the new device can be implanted non-invasively using a syringe and is designed to be absorbed by the body within days, facilitating natural healing without the need for surgical removal. Measuring just 1.8 millimeters wide and 3.5 millimeters long, this pacemaker operates autonomously, generating electricity through a galvanic cell that reacts with bodily fluids, eliminating the need for a separate battery. Its compact design allows for multiple devices to be deployed across the heart, enabling more sophisticated synchronization compared to traditional pacing methods. A soft, flexible wearable device placed on the patient's chest controls the pacemaker, using light pulses to activate it when an irregular heartbeat is detected. The next steps for this groundbreaking technology include extensive safety evaluations and obtaining FDA approvals for human use as the research team progresses through a startup company. Promising results have already been observed in both animal models and human hearts from deceased donors, indicating a significant advancement in the treatment of heart defects in newborns. A coalition of scientists and health organizations has taken a bold step by filing a lawsuit against the National Institutes of Health, or NIH. They are challenging recent funding cuts totaling over $2.4 billion, which they claim are politically motivated and detrimental to vital medical research. The lawsuit, initiated by the American Public Health Association alongside various scientific unions, was filed in Boston's U.S. District Court. The plaintiffs assert that the NIH has violated federal law by failing to provide scientific justification for these cuts. According to the plaintiffs, the abrupt termination of research projects not only wastes taxpayer money, but also halts studies before they can yield meaningful results. They are seeking to restore funding and prevent any further terminations of critical research. The areas impacted by these cuts include essential topics such as HIV prevention, child violence prevention, pregnancy health disparities, and Alzheimer's disease, all of which play a significant role in public health. The lawsuit also claims that since the Trump administration took office, there has been an ideological purge of NIH grants, particularly affecting research on politically sensitive issues. Legal experts have weighed in, stating that the actions of the NIH violate established science-based review processes and congressional mandates that aim to address health equity and disparities. Brittany Charlton, an associate professor at Harvard Chan School of Public Health, pointed out that these funding cuts not only waste taxpayer money, but also hinder scientific progress, potentially delaying crucial medical discoveries. Jesse Rossman from the ACLU of Massachusetts noted that Massachusetts is a hub for medical research, and these cuts threaten ongoing studies that could significantly improve health outcomes. The lawsuit has attracted attention from various stakeholders, including labor unions and affected researchers, who argue that the NIH's funding decisions are politically driven and undermine scientific integrity. The Department of Health and Human Services, which oversees the NIH, has declined to comment on the ongoing litigation, leaving many questions about the future of research funding unanswered. Notably, of the total funding at risk, $1.3 billion has already been spent on projects that would be wasted if the cuts are upheld. David Super, a constitutional law expert, emphasized that the NIH lacks the authority to cancel contracts without following proper legal procedures, complicating the agency's position further. Recent genomic research from the Takarkori rock shelter in the Central Sahara has unveiled significant insights into the genetic ancestry of North African populations during the Green Sahara period, which spanned from approximately 11,000 to 5,000 years ago. The study reveals that individuals from Takarkori share a close genetic affinity with northwestern African foragers, while showing minimal connections to sub-Saharan African populations during the African humid period. This African humid period, occurring between 14,500 and 5,000 years ago, transformed the Sahara into a fertile savanna, fostering human habitation and the development of pastoralism before the region reverted to desert. Archaeological evidence at Takarkori indicates a long history of human settlement, with artifacts dating back to late Akakis hunter-gatherers around 10,200 years ago, and a pastoral Neolithic presence from about 8,300 to 4,200 years ago. Challenging previous assumptions, the study suggests that the spread of pastoralism in the Sahara was driven by cultural exchange rather than large-scale migrations of people. The research indicates that the establishment of pastoralism in the Sahara likely occurred through cultural diffusion, as Takarkori individuals exhibit limited genetic exchange with Levantine groups. The findings also highlight the Sahara's transformation from a green landscape into the world's largest desert, complicating the preservation of ancient DNA. Moreover, the arrival of early farming groups from southwestern Europe between 7,500 and 5,700 years ago marked a pivotal shift in the Neolithic era in the Maghreb, introducing agriculture to local communities. Utilizing ancient DNA, this research enhances our understanding of human history and migrations in central northern Africa, contributing valuable archaeological evidence regarding human adaptations and cultural evolution. Overall, the study provides critical insights into the genetic landscape of ancient North Africa and the complex interplay of environment, culture, and genetics in shaping human history. The Sahara was once dotted with numerous lakes and rivers and teemed with diverse wildlife, as illustrated by rock art depicting animals like hippopotamuses and giraffes. These findings raise intriguing questions about the ancestral relationship of the Takarkori population to modern humans, suggesting a potential link to early out-of-Africa groups with limited subsequent gene flow from non-African populations. Recent excavations at the Porta Sarno necropolis in Pompeii have unveiled a monumental tomb dating back nearly 2,000 years. This significant discovery is part of a collaborative excavation project between the Pompeii Archaeological Park and the European University of Valencia, continuing the area's legacy of remarkable archaeological findings. The site, initially discovered in 1998, remained unexcavated until recent construction work prompted its clearance of ash and stone, allowing researchers to examine over 50 cremation burials. Among the notable findings are two nearly life-size statues, one of a male figure dressed in a simple toga, and another of a female figure adorned with a large cloak over a tunic, highlighted by intricate jewelry. The female figure is depicted holding laurel leaves, a symbol often associated with Roman rituals, along with a cylindrical container that may represent a scroll, suggesting a high social status. Experts believe this female sculpture could represent a significant local figure, possibly a priestess of Ceres, the Roman goddess of agriculture and fertility. Gabriel Zuchtriegel, director of the archaeological park, emphasized that the priestess held the highest public position attainable by a woman in ancient Pompeii. This discovery offers insight into the religious practices of the time, indicating that priestesses played a vital role in Roman society, allowing women to achieve notable social standing. Priestesses of Ceres, known as sacerdotes carreras, were typically from prominent families, suggesting that the couple depicted in the statues likely came from a respectable lineage. The funerary reliefs, including these sculptures, are set to be showcased in an upcoming exhibition titled Being a Woman in Ancient Pompeii, scheduled to open on April 16, 2025. However, experts note that the figures may not necessarily represent a married couple, as the absence of inscriptions leaves their exact relationship open to interpretation. Additional elements, such as plant motifs and an object resembling a papyrus scroll in the female figure's hands, further indicate her elevated status. Researchers at KAIST have unveiled a groundbreaking drug aimed at restoring vision lost due to retinal diseases, with details announced on March 30, 2025. This innovative treatment, developed by Kellias Incorporated, has demonstrated remarkable efficacy in promoting neural regeneration in treated mice. In models of retinitis pigmentosa, the drug led to sustained vision restoration for over 6 months, marking a significant breakthrough in mammalian retinal regeneration. The research team, led by Professor Jin-Woo Kim, focused on enhancing the regenerative ability of Müller glia. They utilized an antibody to neutralize extracellular PROX1, a protein identified as a major barrier to Müller glia dedifferentiation in mammals. This protein accumulates in damaged retinal cells, inhibiting the regeneration process. Interestingly, the study revealed that PROX1 is not produced by Müller glia themselves. Rather, it is secreted by surrounding neurons. Dr. Yoon-Young Lee emphasized the importance of optimizing the PROX1 neutralizing antibody, known as CLZ001, for upcoming preclinical studies. The ultimate goal is to assist patients at risk of blindness, as over 300 million people worldwide currently face vision loss due to retinal diseases. This research is particularly vital given that, unlike cold-blooded animals which can regenerate retinal neurons, mammalian retinas have a limited capacity for regeneration after damage. Kellias Incorporated is committed to advancing this retinal regeneration therapy and plans to initiate clinical trials by 2028. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.